Hello, my name is Arda Hayriabai. I'm a computer science and artificial intelligence student at University of London. In collaboration with BQP Quantum Youth, I'm making this micro-series on quantum computing. The objective of this series is to give you a taster of my Udemy courses, which are fee-based and currently available in Udemy platform. Each of the videos in this micro-series will introduce you to one of my courses and a concept in quantum computing. So even if you end up not purchasing the course, this series might still be a good introduction to certain topics in modern quantum computing. So with that being said, let's get started with our introduction and first video. Hello, and welcome to the Introduction to Quantum Computing course. Throughout this comprehensive quantum computing course, you're going to learn everything you need to know about the foundations of quantum computing and computer science. Afterwards, you're going to learn everything you need to know about Python in order to understand quantum computing and write your quantum codes. And after completing these two parts, we're going to look into complete mathematics for quantum computing. In every single section, we're going to start from the very beginner level, and we're going to increase our knowledge section by section until the advanced level in that certain topic about quantum computing. So we saw about the curriculum of the course, but before diving deeper into all these quantum computing concepts, at first place, what is quantum computing? So behind me, you can see a quantum computer. Actually, quantum computers are quite famous and well known for solving problems that classical computers cannot solve in decades and even 100 years. So we know that the most important unit of the technology of the future can solve these problems just in seconds. So with this information and numerous articles in the internet, you probably heard of this technological revolution and the huge potential that it's bringing to us. So if you want to get ready to this groundbreaking competition, dive into the exciting world of quantum computing and find out all the weirdnesses about the quantum physics, this is the perfect video and the courses for you. So this video is consisting lecture parts from my complete Udemy courses. You're going to get ready to learn about numerous concepts like quantum mechanics, writing quantum codes, quantum algorithms, and quantum protocols. So after completing the big picture in the quantum computing, you can actually going to write your quantum codes and run them on actual quantum computers just like this. So if you're just excited as I am, and if you don't want to miss out this technological revolution and be part of this amazing quantum computing industry and community, this is the perfect video for you. During the video, whenever you have a question, you can always write to the comments. And if you'd like, you can communicate with me directly through LinkedIn or my email. I'll be more than happy to help you in your quantum journey. And after watching this video, if you feel like quantum computing is your hype, that's amazing. There are so many concepts to learn about quantum computing to get proficient and find a workforce in this industry. So in this case, you can always check my Udemy instructor page to find out more advanced concepts and dive deeper into fascinating quantum computing. So afterwards, if you want to further your knowledge about quantum computing and become one of the pioneers of the quantum computing industry, I'll be more than happy to be there with you in your journey. Okay, so without losing any momentum, if you want to learn about this exciting future technology and prepare yourself for the quantum revolution, let's meet on the next section to do an introduction to quantum computing and actually start learning this fascinating technology. Hello, and welcome to the Introduction to Quantum Computing and Computer Science course. With this course, you're taking a huge step to enter the exciting quantum computing, quantum physics, and quantum mechanics journey. I'm feeling both quite excited and energetic to be there with you in this fascinating journey. So once again, welcome. So throughout this introduction course, you will learn everything you need to know about the fundamentals of quantum computing, quantum physics, and computer science. So at first place, what are quantum computers? Quantum computers are expected to change the technological systems we know and both our lives in the upcoming years. Although classical computers and general programming languages like Python, C++, Java, and many more have numerous abilities, some computational problems are extremely hard for them to solve. On the other hand, quantum computers can solve these problems just in seconds. So if you want to learn about this exciting future technology and prepare yourself for the quantum revolution, this is the perfect course for you. This course, as one of the parts of the complete Introduction to Quantum Computing course, has been designed to cover the important concepts to understand the fundamentals of quantum computing, quantum physics, and also computer science. And after completing this course successfully, you're going to learn everything you need to know about the fundamentals of quantum computing, quantum physics, and also computer science. During the course, we will literally start from the very beginning of computing history, we're going to start from the abacuses. So I can assure you that no prior knowledge of computer science, algorithms, or programming is necessary. All you need to have is just the curiosity for the quantum computing and this future technology. After learning about the history of the competition and how the quantum world differs from the classical world, we're going to examine 3 exciting experiments to understand these scientific concepts more solidly. And also, while examining all these, we're going to give plenty of real-world examples, and I can assure you that I will try to explain every single topic as easy as I can. And also, I tried to break down the curriculum into smaller pieces to help you better understand the concepts while you're engaging with the course. Also, during the course, you will have the chance to develop your practical abilities by solving numerous quizzes and a graded assignment. And after you're going to complete the course successfully, you're going to earn a worldwide recognized quantum computing certificate at the end of the course. So once again, congratulations on taking your first step to learn about the technology of the future, quantum computing. During the course, whenever you have a concern, a question, or anything comes to your mind about quantum computing, I will be always there to help you. You can always write through the Q&A, forum, or you can email to me or write a direct message to me through LinkedIn. I'll be more than happy to help you. Once again, I'm sending my sincerest welcoming messages to you to the Introduction to Quantum Computing and Computer Science course. Hi. In this video, we're going to learn about how we can use this course after completing the course successfully. So this course has been designed accordingly to 5 learning methodologies. These are sequential learning, interdisciplinary approach, conceptual bridging, experimental understanding, and collaborative exploration. So you can see all these 5 methodologies inside this course. So about the sequential learning, we're going to start with a strong foundation by understanding the history of computing, followed by the classical programming. This sequential approach will provide a solid background before delving into more complex topics like quantum computing and physics. So I can assure you on this, no matter how hard the subjects may seem, we're going to use the sequential learning in order to approach these concepts in a better way. And also, regarding to the interdisciplinary approach, we're going to recognize interconnectedness of classical programming with classical physics and quantum computing with quantum physics. So integrating these subjects allows for a comprehensive understanding of both classical and quantum computing paradigms, and also we're going to see a more clear and big picture at the end of the course. For the conceptual bridging, we're going to utilize classical physics concepts to grasp the classical programming principles, and similarly, employ quantum physics theories to comprehend the fundamentals of quantum computing. This bridging is going to help us transitioning between classical and quantum worlds seamlessly. As for the experimental understanding, we're going to engage with foundational experiments like the double slit and Schrödinger's cat to grasp the essential quantum concepts such as wave-particle duality and the superposition. This hands-on approach enhances conceptual understanding beyond the theoretical frameworks. And lastly, as for the collaborative exploration, we're going to encourage collaborative discussions and explorations to delve deeper into nuances of quantum phenomena like entanglement. Sharing insights and perspectives fosters a dynamic learning environment conducive to grasping complex concepts effectively. And also, at the end of the course, you're going to see an assignment. So although there are no options about the answers of the assignment, when you're going to write all your ideas to the 7 and a bonus questions, you'll actually be able to give feedbacks to the learners just like you. So this is also another concept fitting into the collaborative exploration methodology. Okay, so we saw about how we're going to approach the course and what are the methodologies of this course, aka Introduction to Quantum Computing and Computer Science. Okay, so with the next video, we're actually going to start learning about quantum computing and computer science. But before diving into these concepts, I wanted to introduce me first because I was also learning computer science and quantum computing just like you did in the previous years. So I can easily say that I was in the same road just like you are now. So my name is Arda Abay. I'm from Turkey. I'm a quantum computing software developer. I'm currently working as a section leader and instructor at Stanford University's Code in Place program. Previously, I have completed a 9-month-long quantum computing and mathematics program organized by IBM and taught by the researchers at MIT and the University of Oxford. I have admitted to this program with full scholarship and I have completed the program with a 99% GPA. During my career, I have worked at Citibank as an early insight participant. And afterwards, with 3 years of teaching experience, I have decided to publish courses on Udemy to share my knowledge with people who have the same interests and are eager to learn. So I'm super excited to help you during this course, and I'm feeling quite lucky to always be there with you during the lectures lectures, quizzes, and assignments. Also, if you have any thoughts about the course in general, I would love to hear your feedbacks and comments. And also, you can feel free to introduce yourself in the forum section of this course. I'm looking forward to your answers. Okay, so with the next video, we're going to start learning about the introduction to quantum computing and computer science concepts. If you're just excited as I am, I'll see you next video to take our first step into this exciting journey.